The pole in the barn paradox. It's one of the famous paradoxes of special relativity, and maybe a paradox that already occurred to you as we've gone through our discussion. We're going to talk about it now, but let me first stress at the outset that there are no paradoxes in special relativity, right? If there were a real paradox, that would mean that the theory was inconsistent. There can, however, be, and this is what we are going to encounter right now, there can be what we might call seeming paradoxes, right? Which are situations where, from the perspective of two different observers, it seems like they're coming to conclusions that are so opposite to one another that there's no way that they can be reconciled. But the thing is, every time, if we carefully examine the situation, we find that we are able to resolve the issues, okay? So I want to show you how we resolve the issues in this particular so-called paradox. All right, to set it up, there are a couple of characters in this paradox, some animate, some inanimate. So we are going to have a pole 15 feet long when it's at rest, okay? We are also going to have a barn. We are going to stipulate that the barn is 10 feet long when you measure it at rest. Yes, it's a pretty small barn, but we're just using it for the example so that we can see what the seeming paradox is. So, what is the seeming paradox? Well, when at rest, if you try to put a 15-foot pole into a 10-foot barn, it doesn't fit, right? Good, that's straightforward. But now let's imagine the following scenario. Let's imagine that the pole is moving toward the barn at very high speed. Let's say it's moving toward the barn at 12/13 the speed of light, really fast. Calculate gamma for that high speed. What do you get? Well, you get 13/5. Now, if you take 13/5 and you use it to look at the length of the pole from the perspective of the barn, or someone who's at rest relative to the barn, the length of the pole drops from 15 feet to 15 over gamma, and with gamma equal to 13/5, the pole's length becomes 5.8 feet. So it seems that from the perspective of the person in the barn, as the pole rushes by, it should fit. But from the perspective of the pole, or someone running with the pole, they come to a very different conclusion, because they say that the barn is Lorentz contracted. So it's not even 10 feet, it's less than 10 feet. Put in the numbers, you get 3.8 feet. So from the perspective of the barn, the pole fits. From the perspective of the pole, it doesn't fit. Seeming paradox. Okay, so let's see that visually so we have the issue clear. Here's how it goes. So we're going to take Gracie to be our observer who is at rest relative to the barn. George will be our carrier of the pole, so he will be running with the pole, making it go really near to the speed of light. So let's set this up and put it into motion. There he goes, and he's going to run toward the barn, and again, this high speed, which we're taking to be 12/13 C, and we want to see what Gracie says, and we will see that she says that the pole fits because it's length contracted. There we go, right? So you saw that from Gracie's view, the pole fit. That may have been a little bit fast. Of course, 12/13 the speed of light is fast, but let's use the wonders of animation to slow down 12/13 C so we can actually observe from Gracie's perspective what's happening. Okay, so here George is coming in, and he's now going, again, at very high speed. From Gracie's view, the pole is length contracted, and because it is length contracted, it fits inside the barn. So that is Gracie's perspective. Now let's take a look at George's perspective, the pole's perspective, okay? So as we described, from his perspective, the pole will not fit, but let's see that. So his view, it went really fast. Maybe I should show you that one again. So from his view, he's going by at such a high speed that the barn is shrunk. So there it is. The barn, from his view, is length contracted. So his pole, it didn't fit even when it was at rest. Now it doesn't fit even more dramatically, because from his perspective, it is the barn that's in motion, the barn is contracted, and therefore he comes to his conclusion that it doesn't fit. Okay, that is the paradox, or the seeming paradox. So the question, of course, is, what is the resolution? We want to know who is right, right? From the pole's perspective, it doesn't. The barn's perspective, it does. And the answer is, and you perhaps are not surprised by this answer, they're both right, right? They're both right. Now, how can they both be right? Well, let's just clarify that a bit. When we say they're both right, what I mean is each can make perfectly good sense of the other's seemingly contradictory claim, right? They have different perspectives, different claims, yet they can reconcile them. Why is that? Well, here is the key point. When we talk about the length of an object, that invokes a notion of simultaneity, right? We are referring to the measurement of the front and the back of the object at the same moment in time. Now, if two observers are in relative motion, we already know that they have different conceptions of simultaneity. They will have different conceptions of length. So one can conclude, and rightly so, that the pole fits inside the barn, and the other can conclude, rightly so, that it doesn't, because they have different conceptions of simultaneity. They therefore have different conceptions of the length of objects. Now, to make that idea a little bit more precise, let's look at their different conceptions of simultaneity a little bit more closely. And to do that, let's adorn the pole and the barn, say, with clocks. So we will now have a pole that has two clocks on each end, and the barn will have a clock at each opening of it. And we want to understand from each perspective how the other comes to the seemingly contradictory claim. If we can do that, if we can tell a coherent story about how the other came to their bizarre-sounding claim, all of the seeming paradox will go away. So let's do that. So, question is, from Gracie's perspective, from the barn's perspective, how does Team Pole arrive at their crazy answer? Well, let's take a look. Now again, let me just set this up. From Gracie's perspective, right, the pole is coming in this direction, right? Now we know that if a reference frame is in motion, its clocks from her perspective are not synchronized. We know, in fact, that the clocks in the front of the motion are late. They are behind clocks that are to the right of the motion. So what that means is, when the pole comes in, I want you to look at the readings on the clocks. And what we're going to see is, Gracie will say that from George's perspective, the position of the back of the pole will be noted first because those clocks are ahead. The position of the front will be noted later after the pole has had time to move outside the barn. And that will explain, from Gracie's perspective, how it is that George claims that the pole does not fit. Let's see that. So there are the clocks, right? Notice that this one is behind. It's the leading clock, so it's behind. 7 o'clock, 7 o'clock. So from George's view, the front and the back of the pole at 7 o'clock were not inside the barn. But Gracie says, that's merely that your clocks were out of sync. She says the front and the back were in at the same moment of time. It's just that her notion of the same moment of time is different. So that's how she explains how it is that George comes to this strange conclusion. So here it is, a couple of stills of the key moments of that animation. From Gracie's perspective, the clock on the trailing edge of the pole reads 7 o'clock when it's just entered the barn. But by the time the front clock reads 7 o'clock, since it's lagging behind, the front of the pole has had time to exit. That is how she makes sense of his claims. Now, let's do the other direction. From the pole's perspective, how does George understand that Gracie and Team Barn arrive at their crazy answer. It's exactly the same collection of words, right? Now, from George's view, right? So George is coming in this direction, right? Now, but from his view, that means that the barn is coming at him from the left in the animation that we have here. That means that clocks on the barn, the clock on this side will be late relative to this clock over here, which means that from George's perspective, Gracie will not be measuring where the front and the back of his pole is at the same moment in time, and that is going to be how he resolves her claim that the pole fit. So what George will say is, because Gracie's clock over here is ahead of the clock over here, he's going to say, and we'll see it in a moment, that she is actually locating the back of the pole early relative to the front. So she's saying the back is in, but then according to George, the barn continues to move, and then after the barn moves, she works out where the front of the pole is, and there has been time for the front of the pole to enter the barn because of that asynchrony. Let's take a look at that one over here. So we'll now look at the clocks from George's perspective on the barn. Again, he's going to find that this clock is lagging compared to that clock over there. So he doesn't think he fits, but he notices that at 7 o'clock and at 7 o'clock, according to Gracie, because the barn clocks are out of sync, he actually fit, right? So let me just quickly show you that one again. So he's heading in, and he's looking at the barn clocks, trying to understand how Gracie says he fits, which means he knows that Gracie says at one moment both ends are in. 7 o'clock, that end is in. 7 o'clock, that end is in. But from George's view, that's merely because the barn clocks were out of sync with one another. He claims that in reality he doesn't fit, but understands how it is that Gracie comes to this conclusion. That is the resolution of the pole in the barn paradox. Let me show you a couple of still images just to solidify the idea that from George's perspective, what he is saying is that Gracie's clocks, the barn clocks, are not in sync. So indeed, when the barn clock reads 7 there on the left-hand side, one end of his pole is in, and even earlier than 7 o'clock, the other end is in, so it easily made it into the barn. So from his view, he understands why it is that Gracie would say that the pole fits, but he attributes it to the asynchronous nature of Gracie's clocks. All right, let's take a look at a little demonstration where you can play with this. So this is just the pole in the barn experiment done in the traditional way that we have been doing things. This over here is our schematic representation of the barn. Here we've got the pole, and here you've got the barn's perspective and the pole's perspective, both here at the same time. So if you choose the relative speed between these guys at will, you should do this on your own, but let's say we choose it to be high speed, and then we play it at high speed. The barn says that the pole fits. Good. The pole, however, says that it doesn't fit. And again, the resolution simply has to do with the fact that they do not agree on what happens at a given moment in time. It's the relativity of simultaneity that allows us to understand both of these perspectives.